Okay, today's lecture is on definite integrals. So we already went over indefinite integrals, right? Wait, I need to share my screen.
You shut up. Yeah.
Okay, very good.
Like, I don't know, I gotta come by here, like,
So we've already talked about indefinite integrals. And indefinite integrals are when we simply write an integral symbol. And so we would say that the indefinite integral of f of x is written like this. Okay? So this is called an indefinite integral. What is a definite integral? A definite integral looks like this. It's the same integral symbol, except now we have what we call a lower limit and an upper limit. So this is how we write an indefinite integral. Some people write the a and the b next to the integral symbol. Some people write it above it. Personally, I prefer it when it's next to it. It's slightly to the right. I think it looks more aesthetic that way. All right, so what does the definite integral correspond to geometrically? So what does this actually mean? So we say the integral of f of x from a to b. What does it actually mean?
Hold on.
If you guys remember back from the very first lecture I gave, this actually corresponds to the area under a curve.
First lecture ever of this unit.
First lecture ever. So I remember it because I'm your teacher. If you have a graph of f of x, maybe it's like this kind of squiggly line. And here's my x-axis, right? The lower limit corresponds to this here, and the upper limit b corresponds to that. And all this definite integral corresponds to is the area under this curve, bounded by the curve itself and the x-axis, from the x value a all the way to the x value b. So it is the area of this region. Make sense? And so that's why we say that an integral is the area under a curve. Derivative is the slope of the curve, and an integral is the area of the curve. Under the curve, yes. Under the curve and above the x-axis. Okay? So these correspond to each other. So we could do a quick example. Are we all good with this slide? Yes. We could do a quick example. Suppose I asked you, what's the integral of 3? So what's the integral of 3 from the limit 1? So the lower limit 1 and upper limit 5. Any guesses? No, not 15. We could graph this curve, right? Because my function f of x is 3, right? My function f of x is 3. And so if I were to graph my function, it would just be a horizontal line, right? It would just be the line y equals 3. Yep. And all I'm trying to do is find the area under this curve between the values 1 and 5. So if this is 3, and this is my x value 1 and my x value 5, then the area would be 12, right? Yeah, not 15, 12. Right? Because my height is 3 and my width is 4. And so we would say that this integral here equals 12. It's just the area under a curve. Any questions? Hmm? Oh, too easy? Okay, let me continue. We could do another one.
Question actually.
Yes.
What case would that be x is equal to 3? Or are we not doing that?
X is equal to 3?
Yeah, because it's 3 there is equal to y.
Right. Yeah, so the f of x always corresponds to the y values. And this 1 and 5, that's the x values.
Okay.
Yeah. let me do another example. Let's say we were trying to find the integral of x dx from 0 to 4. Okay? So in other words, we're trying to find the area under the curve. We are trying to find the area under the curve f of x equals x from the x value 0 all the way to the x value 4. And so we could graph it. We could try to figure out this area. So how do I graph f of x equals x? Anybody? The graph of f of x equals x,
Yeah, what about it?
what is it?
X.
It's a line of slope 1 that goes through the origin, right? So this is the graph of f of x equals x. And all I'm trying to do is figure out the area under this curve from the x value 0 all the way to the x value 4. Correct? So I'm trying to find the area under the curve from 0 to 4. And so that would correspond to this area, right? And so what is that area?
The area of
It would
it.
be 8. Very good. It's 8 because this width here is 4, and this height is also 4, right? That's because this is the point 4, 4, if it's going to be on the curve y equals x. And so if I have a triangle of width 4 and height 4, then the area is going to be 1/4 times 4 times 4, which equals 8, right? And so that means that this will equal 8. Okay. Any questions? Okay, let's also talk about what happens when the function is negative. So you're also going to encounter some cases. You're going to encounter some cases. So suppose that this is my x-axis. Sometimes f of x can be less than 0, right? So your curve might look like that. So if this is the curve f of x, how would I evaluate the integral of f of x from a to b? So integral f of x a to b. How would I do that when part of it is negative? So if this is a, this is b.
2 minus it.
Yeah, that's a good guess, which would be correct.
Is that right?
Yeah.
Dependent?
I don't know.
No?
I don't know.
Say yes.
I don't like to compliment people.
No?
Not really.
Do you like any compliments?
No.
Yes, sure.
So what happens when a function is negative is that this area is positive and this area is negative. Okay. So when a function drops below the x-axis, we consider it to have a negative area because it's no longer the slope that's under the function, right? Actually, it's so the area that we care about is always bounded between the x-axis and the function. But when the function drops below the x-axis, it corresponds to a negative area.
It would cancel out.
In this case, they would almost cancel out, right? This one looks a little bigger than the minus, so it'd probably be a little positive.
Yeah.
Okay, any questions?
They call the numbers.
Yes, we can do some numbers. So suppose now I were to ask you, what is the integral of -4 to 0 of f of x, sorry, of x dx? Okay, so now we have the same exact function as just before. So this is what the function looks like. But now we care about the area from -4 to 0, right? And so now we care about this area. Okay. And so what would the integral be in this case? Yeah, -8. Because we have the same exact area, but now it's under the x-axis. And so the integral is now -8. because the function drops below the x-axis. Any questions about this?
Wait. Well, isn't there a rule on the top? I haven't done that yet.
Huh?
There's stuff on the top, you haven't done that yet?
There's no stuff on the top.
Why?
I'm integrating from -4 to 0, so it's just that area.
Oh, God.
Okay. All right. I could also ask you guys, what is the integral of f of x equals x dx from -4 to 4? 0. Why? From -4 to 4. Why is it 0? Okay, I didn't really hear your explanation. The reason why it's 0 is because now these areas cancel out with each other. Okay, so when we're integrating from -4 to 4, this area is -8, but this area here is +8, right? And so when we go from -4 all the way to 4, we actually have a total area of 0.
I thought you couldn't have a negative area.
We do have negative area when the function is below the x-axis. Vincent?
Do you subtract by the bottom number? Or the top number?
So this area is negative and this area is positive. Okay, the reason is because all of this area is below the x-axis, and so we consider it to be a negative area.
No other way.
And so actually the areas cancel out and we say that the integral is equal to 0. Any questions?
No, that's cool. Is that it?
Nope, I'm going to continue. Okay, here's another very important property of indefinite integrals. The area is only, how do I say this? Let me just tell you the property. Okay, you guys need to know this. Basically, all this is saying is that when we flip the limits of integration, so when we flip a and b, the integral becomes negative. Got it? Let me try to explain this graphically. So suppose we had our integral of f of x from a to b. So here's a and here's b. The integral is positive when we go from a towards b.
Yep.
Okay, so when we start with our lower limit of a and end with the upper limit of b, we end up with a positive area here because we're going from left to right. We're going from the smaller number to the bigger number. However, if we started with the bigger number, so if we're starting with b and going towards a, then now the integral is going to be negative.
Oh, so you're counting backwards.
Yes. So the area is always measured left to right, meaning that if you measure right to left, that makes the area negative. That makes the integral negative.
So it's really important to remember that A is on the bottom of all this. For the positive ones.
The thing is, the bigger number could be at the beginning. So b could be the bigger number, but that means you have to invert the area. You have to invert the integral. Okay? I will give some examples. So we just talked about the integral, what was it? 1 to 5 of 3 dx. And we found that this equals 12, right? That was our previous example. But if we were to integrate 5 to 1 of 3 dx, then this would actually be -12. So graphically speaking, if our function here, this is f of x equals 3, right? And here is 1 and here's 5. So we care about this area here. So if we're integrating from 1 to 5, this is a positive 12. But if we go from right to left, it's actually a negative area. It's going to be -12. Okay. So it's not just area, it's also, we care about the direction in which the x is moving. So if we're moving from 1 to 5, it's positive. Moving from 5 to 1, it's negative. Questions? Let me do another example just to make sure you guys get this. What if we were integrating 0 to -4 of x dx? Anybody have the answer? So here is x. How would we integrate from 0 to -4? Yes, the answer would be 8. Okay, do we all understand why it's 8?
Give me a second.
So we're integrating x from 0 to -4. So we're starting at 0 and we're going towards -4.
So 1, 2, 3, 4.
Okay. So purely geometrically speaking, this area is 8, right? But it's under the x-axis, so it's -8. But we're also starting from right and going towards left. So it's -8. So it's +8.
I already know. Did
that make sense?
24 something.
Okay. So April 3rd to 12th.
She couldn't wait.
Yeah, I can't wait either.
You don't think it's been.
Any questions?
You're gonna miss.
I'll miss you guys when you graduate, but not until then.
Who's gonna annoy you last?
See. Let me tell you guys about another important property of integrals. Okay. Do we understand why this is true? So all I'm saying is that when we're integrating f of x from a to b, this is the same as if we added two integrals from a to c and also c to b.
Not A to B though.
A to c and then c to b.
Not A.
So do we see why this is true? Yes, right? All this is saying is that now we're adding two separate areas together. So if this is A and this is B, and C is somewhere in the middle, then this right side here, this integral corresponds to that area, and this integral here corresponds to the right area. And so when we add them together, we can express that as a single area, which is the integral from A to B.
What time do we have a lecture?
Hmm?
How short time is the lecture?
Maybe 5 minutes.
Maybe the work after.
Any questions about this?
No, we're good. Keep talking. Nobody's listening to that. There's too much.
All right, two more properties of definite integrals. Guys, be quiet for a few more minutes.
Second lecture. Okay.
Okay, make sure you know these. These are very simple. All this is saying is that integrals add with each other, and they also can be multiplied by constants. So if c is a constant, you can always take it outside of the integral and just calculate it like that. Any questions about the whole thing? Vincent?
That's it. Let's go.
Huh? The bottom equation is just telling us that if we have something added within the integral, we can split it up into two different integrals, which is the same as what you guys were doing for indefinite integrals already, right? Yes. Any other questions? Next week. Okay, let me pass out the classwork.